Okay, in this problem we have the identity sine squared minus tangent theta over cosine squared minus cotangent theta equals tangent squared. We want to establish this identity. Again, typically you want to start with a more complicated side. And it's easy to see here that the left-hand side is far more complicated. One common technique when you're working with trigonometric identities is to turn everything into sines and cosines. This gives you the advantage of often introducing fractions, either fractions that you can add together or fractions inside of fractions. And so rewriting, we would have sine squared theta minus sine theta over cosine theta, all over cosine squared theta minus cosine theta over sine theta. Producing for us a pair of complex fractions in both the numerator and denominator. And once you do have some complex fractions, we like to get rid of those. Those could be eliminated by multiplying through by your common denominator, both top and bottom. In this case, our common denominator will be sine of theta, cosine theta. Right, taking our two denominators. And so we multiply through. And now distributing, look at sine cubed theta, cosine theta, distributing the first term. In the second term, the cosines will cancel out, giving me sine times sine, which is sine squared. In the denominator, we'd get cosine cubed theta times sine of theta, the first term. The second term, the sines will cancel out. Anyways, cosine times cosine over cosine squared theta. You might want to pause the video for a moment and think to yourself, what might I try next? Well, one common thing to do, again, which gives us a way of possibly rewriting stuff, is to try to factor. In this case, if you examine your numerator, there's a common factor you can pull out. And if you examine the denominator, you can see there's also a common factor you can pull out. In the numerator, we can take a sine squared over both pieces. So we do that. That would leave us with just a sine theta, cosine theta, and a minus 1. In the bottom, we have a cosine cubed, a sine, and a cosine squared. So we can pull out the common factor of cosine squared. Now when you do that, we'd be left with cosine sine, which I'm just going to go ahead and rewrite as sine cosine, because it's multiplication, and minus 1. And then we look at what we have, and hopefully when we factored, something will now cancel out, and that's exactly what happens here. We have a sine theta, cosine theta minus 1 in both top and bottom that we can take out, leaving us finally with sine squared over cosine squared. But keep in mind where we want to be. We want a tangent squared. And hey, guess what? We have a tangent squared. So, now I'll write our answer, and we're done. So hopefully this example gives you a little help, as you start working and struggling through some of these identities.